Good afternoon. You are very keen. Good afternoon, everybody. Good afternoon. We are open.
Thank you.
Good afternoon. 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 Very good afternoon.
Good afternoon.
Good afternoon. Cold?
Very.
Good afternoon. 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 Very good afternoon. 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 Very good afternoon to you. Good afternoon. Good afternoon. Good afternoon. Good
Afternoon
afternoon.
now. Ooh.
2 o'clock. Good afternoon.
Time just keeps ticking on, doesn't it?
Yeah, when you have fun.
Yeah.
Good afternoon.
I came back.
Good afternoon. That's good.
Algorithm just yet.
Good afternoon. 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 No, you're way too early. Good afternoon. Good afternoon. Good afternoon.
Hi there. Hello. Are you Peter?
That's me.
Is your lecture you're doing?
Mhm.
I'm from Employability Points.
Okay.
And I think you should have got an email about me coming in for the beginning of your lecture for like 30 seconds to say about employability points. I mean, if it doesn't work for you, it's
No,
up to you, but
fine.
is that okay?
Yeah.
Okay.
Yeah.
Thank you.
It's just people come along. Yesterday was Kent Union. Then before that, somebody else who wanted to make announcement, and it's sort of
Sorry.
no,
I
it's
think
fine.
you definitely got an email. I can't remember the lady I was emailing from your school who arranged it.
Okay.
She said that.
Francis.
Yes, it was Francis. Yeah. Yeah. I'll take up 1 minute.
Yeah, no worries. But wait till
Yeah, I'll wait
people are
until
there.
just
Yeah.
yeah.
Good morning.
Good afternoon.
Oh, afternoon. Thank you.
Sorry. I'll be back.
That's what they all say. Good afternoon.
Afternoon.
Good afternoon. Good afternoon. Good afternoon again. Good afternoon. 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 Brilliant. Welcome. Good afternoon. Good afternoon. Good afternoon.
Are we for someone? Coming.
Your call. Good afternoon. 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 Not morning. Good afternoon. Good afternoon. Not one of mine.
Master, aren't you?
Sorry?
The Rutherford Master?
Yes,
Yeah.
indeed.
So,
I am.
Yeah, because I'm part of Rutherford, because I was in
Oh, are you?
Parkwood. Yeah, and I think I went to a few things in my first year, and I remembered you from that.
Where did you live?
I lived in Lippiackle in Parkwood.
Yep, that is Rutherford territory.
Yeah.
But I don't think I ever encountered you.
You did?
Did
years.
I?
Only once or twice, very briefly. So and I'm in third year now, so I think it was my first year. So quite a while ago now. I think it was at maybe, I think it was a Christmas
Was
meal.
it anything horrible?
No, I just met you at
Oh, I
the
see.
Christmas meal. Like
Yeah.
Not-
Yeah, not anything disciplinary
No,
or, you know,
no.
smoking weed and...
Oh no. I wouldn't have brought it up if I had.
Well, I mean, it's forgiven, you know. Once you are through the system, you're through the system. Shall we? You want to?
Yeah. Would you mind sort of introducing? Would you mind?
Right, ladies and jelly beans, a most wonderful good afternoon. And before I get really started with you, can I hand you over to Meg
Yeah.
from the employability points?
Yeah.
Meg.
Really quickly before your lecture starts, I'm Meg. I'm from the employability points. I'm the ambassador, Christine. I just want to tell you really quickly what the scheme's about and how you can get involved if you're not already. So it's an award scheme on campus for University of Kent students. If you do anything extracurricular, you could be getting points for doing so. So if you're in any societies, speech groups, if you have a part-time job, if you attend events, open lectures, etc., you could be getting points for doing this. In your second term, you can convert points into rewards. So for 200 points, you get an internship, 150 points, you get work experience. Also, there's work placements, work shadowing opportunities, event days, different things. So in order to get involved, you can go onto the University of Kent website under My Folio, and from there you can log the points. And then in your second term, you'll get an email with all the awards that are being offered and how you can apply. If you have any more information, then have a look on the University of Kent website under employability points. Yeah, thank you.
Thank you very much. So definitely worth thinking about. Looks always good on your CV, although I'm not entirely sure with the definition of extracurricular activity. When I was young, I was warned against any extracurricular activity because it was, you know, people thought it's something usually only involves adults. Extracurricular and yeah, anyway. Right, so what I want to do with you today is just quickly go through some of the calculations that we started yesterday, and I showed you the different methods that I am aware. I'm pretty sure there are lots of other methods available where you do calculations with respect to molarity or something like that. I can only reiterate, whatever method you use, I honestly don't care as long as you get the right result. If it's correct, great. If it's not correct, then obviously, Houston, we have a problem. So, what I want to do with you is 3 typical calculations that you almost certainly will encounter in a test or an exam. Right? So I don't think I give too much away, but it's definitely worth practicing that stuff. And as I said previously, you find loads of practice questions on my website, Practice Calculations website. Please, please, please make use of this resource because that's what it's there for. It's safe, it has lots of video tutorials. Please make use of it, okay? So yesterday I showed you how I calculate, for example, a typical question where it says, you need to make up a solution. Let's say a substance has a molecular mass of 180 gram per mole, and we want to make up 200 milliliter of 1 molar solution. Let's just keep things simple and easy. It's Friday afternoon. We all want to go home, right? Yeah. And so the question is, how many grams do you need? And my favorite method, because I don't need to think about anything, is this dimensional analysis or conversion factor or whatever you want to call it. And I start with, what am I looking for? What's the unit that I'm looking for? Very clearly, it's grams. So I write that down, grams. In my givens, do I have grams anywhere? Do I have grams? Where? In the molecular mass, right? Yeah? So I write it so that the gram is on top of the fraction line. So I've got 180 gram per mole. And I see that the that the grams is in the right place, so that's good, yeah? But I need something to get rid of the moles. Do we have moles anywhere? The moles are hidden in the capital M in the molar, which stands for mole per liter. So here I have my mole. And what I need to do now is I just simply multiply this guy here so that the moles cancel out. So I have 1 mole per liter. And what I see is, hey, cool, the mole cancel out. What do I have left? The units. Loud? I have gram per liter. Yeah? So gram is good, but I need to get rid of the liters now. Now let's do the same thing again. Do I have liters anywhere? Yes, I do. I have got liters in here. And I just simply write the 200 milliliters as 200 times 10 to the minus 3 liter. The 10 to the minus 3, that's the milli. And what I see is now the liters cancel out. What's the unit that is left? Grams. The unit that is left is grams. What is the unit that I want? Grams. Hey, cool. Life is good. I can stop now because I've got the unit that I want. So I have 180 grams times 1 times 0.2. And that would give me 36.0 grams. Is that right? Yeah. So I need 36 grams to make up this 200 milliliter of 180 gram per mole, 1 molar solution. Totally, as my friend Sergey would say, simples. Right? I'm a victim of advertising. So this is basically the my approach, conversion factors, dimensional analysis. This is a question, obviously with different numbers, but you can actually bet that this will come up in an exam or in a test. Yeah? I can almost guarantee that. I told you that sometimes you will come across the expression weight per volume and the percentage, so percentage weight per volume. Let's say we have a 2% weight per volume solution, and our substance has a molecular mass of, let's say, 100 gram per mole. I now want to know what is the molarity of this solution. So obviously I need to convert the percentage into a molarity. Do you want to try this yourself for a couple of minutes and see if you can do that, if you can solve that? So I give you a couple of minutes, and please feel free to have a chat with people sitting around you, how you would approach this problem. How can you solve this problem? See if you can do that.
What the double M står for?
Percent.
And percent?
2%
Yeah.
weight per volume.
Yeah, and then it's two small M's.
Oh, molecular mass.
Okay, yeah.
Sorry.
A big M, right?
Molecular mass. MM stands for molecular mass, as you already know, because that's the right unit. So, any ideas how we can approach that? Well, we know what 2% weight per volume actually means. I told you last time. It means 2 grams per, what's the volume for that? Exactly, 100 mil per cent. Centum, 100. So per 100 milliliter. Stupid question. If it's 2 gram per 100 milliliter, how many grams per liter? How many grams is that per liter? 20. 20 grams per liter. I just extend by factor 10. 10 times 100, that gives me 1,000 milliliter, which is a liter. 10 times 2 is 20. So that's 20 gram per liter. And we want to express that as mole per liter. So what's the unit that I'm looking for? Just said it. Mole per liter. I have somewhere moles? Because that is the top bit that I'm looking for. Do I have moles anywhere? Yes, where? In the molecular mass. So I've got 100 grams per mole. But Sod's law, the mole is below the fraction line, right? So what I need to do is just need to write it upside down. So I write mole per 100 gram. Because I can write it as 100 gram is the equivalent of 1 mole, or 1 mole is the equivalent of 100 grams. Same difference. It's actually very bad English. Same difference. Doesn't make any sense, but that's a different story. So we've got mole in the right place. Hey, cool. But we have the issue with the grams. Can we find something that has grams in it? In what we've been given. Do we have grams anywhere? 20 grams per liter. So if we write it in such a way that the grams cancels out, it would look like 20 gram per liter. Now let's have a look. What cancels out? The grams cancel out. What's the units? What are the units that I have left? I've got mole per liter left. What do I want? Mole per liter. That means I can now stop with my conversions and I just simply say life is good. So I have 20 over 100 mole per liter. And I think that gives me 0.2 molar. Cool, hey? And of course, we can convert that back. If we have a molarity and we've got a molecular mass, we can do exactly the opposite, but exactly the same method. And we can say, what percentage solution is that? Exactly the same method. It's on my website. You can do a little bit of calculations with that. Okay? Happy with that? So really, the biggie here is that you remember the percentage weight per volume simply means gram per 100 milliliter. Occasionally, for example, in one of the practicals, you will encounter also percent volume per volume. Or you see that on your vodka bottle. Volume per volume. What this means is just simply the substance that you have is not expressed in grams, it is just simply expressed in a volume. So alcohol, for example, which is a liquid, and if you have a 40% volume per volume, that's roughly vodka. That means you've got 40 milliliter of vodka in a total of 100 milliliter water. Easy. Okay, now here is another question for you. Water. Wait, what does vodka actually mean? Anyone? Have we got any Russians? What does vodka mean? Vodka means water. Okay, just to do a little bit of, general knowledge. What does whiskey mean? Sorry? Forget the of life. Whiskey is whiskach, I think, Gaelic. Can't speak Gaelic, but which again means water. Whiskey is water. So next time you get stopped by the police and they say, have you been drinking? Yeah, just water. And then they ask you to, do the test and, yeah. Okay, what's the molecular mass of water? Loud? 18, what? 18 bananas. 18 grams per mole. How much does a liter of water weigh? Loud? 1,000 grams. Brilliant. Okay, what is the concentration of water? 1. Concentration of water is 1? Are you sure? Or you just give me... What is the concentration of water? Is he going totally bonkers now? Concentration of water? Can you have a concentration of water? How bizarre is that? What is the concentration of water? 100%? I want it in mole per liter. Concentration of water. Okay, concentration. What's the unit? Loud? Mole per liter. So we are looking at mole per liter. Do we have mole anywhere? Yeah, where? We have it in the molecular mass. But we have to write it the other way around. We have to write it upside down, right? So we have mole per 18 gram. Mole is in the right place. But we need to get rid of the grams. Do we have grams anywhere? In 1,000 gram per liter. So what we do is we just simply write it as 1,000 gram per liter. What happens to the gram? Cancel out. What are the units that we have left? Mole per liter. What do I want? Mole per liter. Life is water. So I've got 1,000 over 18 mole per liter. And that gives me a concentration of 55.56 molar. Water has a concentration of 55.6 molar.
Then what's the grams per litre?
Sorry?
What's the grams per litre then?
That the grams per liter, that tells you how much the water actually weighs. Now, Ben was absolutely right when he said earlier, let's convert that into percentage. We know that we have 1,000 grams per liter. How many grams do we have per 100 milliliter? How many grams do we have per 100 milliliter? 100. And we know that 100 grams per 100 milliliter, I can also write this as 100% weight per volume. And coming back to Alex's question, what is this 1,000 gram per liter? This guy here, it indeed has a technical term, that's the density of water. The density of something just tells you how many grams a certain volume weighs. Make sense? With this question, I caught out loads of PhD students. You know, you just have a nice chat in the lab. A PhD student, oh, by the way, what's the concentration of water? And they go, what? Concentration of water? Water? No. You have to have something dissolved in water. No, you don't. You just, you know, it's a concentration, isn't it? You can't have the concentration of water. It's crazy. No, you can. So next time Klapper asks you, what's the concentration of water? 55.56. It's one of these, you know, one of these general knowledge questions. Jeremy Paxman. University challenge. What's the concentration of water? 100%. Yep, you're right, but molar. Okay, now we're talking about water and diluting things. Again, that is an operation that you will do millions of times. For example, we have what is called a stock solution. This stock solution is something that has been made up. And thank you. This stock solution you make up once, so that you don't spend a lot of time to make up this solution every time you need it. It's a little bit, you know, stupid to make up stock solutions all the time. You just make it up, large tank, large canister. And from this stock solution, you just simply then take whatever you need to make what is called a working solution. So, for example, you have a stock solution, let's say a 1 molar stock solution, and you want to have 100 milliliter of 100 millimolar working solution. And the question for you now is, how much of this stock solution do I actually need to make up these 100 milliliter of 100 millimolar solution? Let's just simply try to envisage what we are tasked to do. So we have here our stock solution, which is 1 molar. That's our stock. And we want to take out a little bit. And dilute it, create our working solution. So that now we have 100 milliliter of a 0.1 molar, that's the same as 100 millimolar, working solution. Right? How much do I actually need to take out from my stock to make up this solution? The approach is not terribly difficult. You probably, most of you, have seen the equation for that, which is C1 V1 equals C2 V2. Does that ring a bell for some of you? Who has seen that equation? Hands up. Who has not seen that equation? Hands up. Ha, brilliant. Brilliant. This is what usually is quoted, this equation. Might be useful to remember it. How can we actually address this problem that we have? We need to take out a certain volume from the stock and dilute it so that at the end we get 100 milliliter of a 100 millimolar solution. But how big? How big is this volume? We don't know. But what we can do is we can make a sort of a very simple assumption. We can say, in our working solution, in this working solution, we have a certain amount of particles. We have a certain number of moles in that. Number of moles. Yeah? Can we calculate how many moles are in this working solution? Of course we can. Let's just simply do this calculation, yeah? Moles, so that is what I'm looking for, mole. Do I have in my working solution, do I have anything with moles in it, with the unit? Loud? 0.1, exactly, 0.1 mole per liter. That's in this capital M. 0.1 mole per liter. Mole is in the right place, great. Now I need to multiply that so that the liters go away. And do I have liters anywhere? Yep, I've got my 100 milliliters times .1 liter. Let's do it like that. Yeah? Liters cancel out. What's the unit that is left? Mole. What is the unit that I want? Mole. Simples. So I get 0.1 times 0.1 is 0.01 mole, or 10 millimole. Correct? So I want to have in my solution 0.01 mole. I want this in the solution. Where do these 0.01 mole come from? They come from the stock. There's no, there's, unless somebody is peeing into our working solution, there's no other way where this thing can come from, this 0.01 mole. So we now need to find out from this solution here that we have what volume do we need what volume of the stock solution gives us these 0.01 mole. Because that is what we need. True? So, we know that our concentration is 1 molar for the stock solution, or 1 mole per liter. So let's employ dimensional analysis. Hey, why not? Haven't done that for a while, hey? What is the unit that we are looking for? It's the volume. It's liter. Do we have liter anywhere? One mole per liter. Liter is not in the right position, but we just simply turn that around. So we have liter per 1 mole. Liter is great. Well, we need to get rid of the mole. Do we have anything where we have moles? Yeah, exactly. That's what we just calculated. We want to have 10 times 10 to the minus 3 mole. So we just multiply that. 1 times 10 to the minus 3, that's the millimole. You see, mole cancels out. Oh, sorry, that's 10. 10 times 10 to the minus 3. I missed the 0. 10 times 10 to the minus 3 mole. Mole's gone. The unit that's left is liters. Cool stuff. So my volume that I need is 10 times 10 to the minus 3 liters, or 10 milliliter. Hang on, what have we just done? Let's go back. Stock, 1 molar. Working, 100 milliliter over 0.1 molar. We said we need 0.01 mole here. That's the amount of moles in our working. Where do we get them? We get them from this stock solution, zero 0.01 mole. We nick them from the stock solution. We just simply figure out how many milliliters we need to get it from the stock solution so that we get is 0.01. And we figured out it's 10 milliliter. That gives us this 0.01 mole. Okay, that's the long version. The short version of that is just simply we say the moles from the stock equals the mole from the working. And we can get the moles just simply by multiplying the moles volume 1 times the concentration 1, that's from the stock, equals volume 2 concentration 2. So that's volume 1, that's from the stock, and the concentration from the stock, and that's the working solution, and that is the working. What does that give us? It gives us the moles. It's exactly what we've done the long way. That is where this V1C1 or C1V1 equals C2V2 comes from, this equation. And all we need to do is we just simply need to say, right, we know this equation. All we need to do is we need to solve this equation for V1. So we have V1 equals V2C2 divided by C1. V1 is the volume of the stock solution that we need. V2 is the volume of the working solution, concentration of the working solution, divided by the concentration of the stock. This one here is probably easier to remember. I have a slightly different way of visualizing that. I'm an incredibly visual person. I know you are excited to see me. I see it as a guy comes into the pharmacy. With a prescription in his hand. where the doctor said, give that guy certain amount of a certain medicine with a certain concentration. That's what the guy has in his prescription. And on the other side of the counter, there's this hot assistant totally hot. And she says, or he says, I don't want to make any presumptions. Oh, we are sorry, we only have this and this in stock. And the short form for me is I want times I want. That's the fraction line here, divided by we have. We have, that's the stock concentration, but I want certain volume, certain concentration. That's how I see it. You might see it totally different, or you might want to use the V1 C1 equals V2 C2. Let's do a simple calculation. We have a stock solution. We have a 100 milligram per milliliter solution. Is this a valid concentration? 100 milligrams per milliliter. Yeah? Are you sure? Well, if you are sure, then I am sure. Absolutely. 100 milligram per milliliter. And I want 10 milliliter of 100 microgram per milliliter solution. Ooh. You want to have a go? Try if you can figure out how much of this stock solution we need. Got it? Right. We want 10 milliliter of 100 microgram per milliliter solution. but we only have 100 milligram per milliliter solution. Now what we could do is we can convert the 100 micrograms into milligrams. How many milligrams is 100 micrograms? Hundred micrograms in milligrams. 0.1. You're absolutely right. So we have 10 milliliter times 0.1 milligram per milliliter divided by 100 milligram per milliliter. Hey, cool, actually we can cancel the milligrams and milliliters. So what we've got left is 10 milliliter times 0.1 divided by 100. And you can either use your calculator or your fingers, and that gives you 0.01 milliliter or 1 over 100 milliliter. Well, it's the same as 10 microliter. So we need 10 microliter of our stock solution to get our working solution, our 10 milliliter of 100 microgram per milliliter. You will do these calculations all the time. You will do dilutions this way all the time, I can guarantee you. Go to my website. There are plenty of practice questions. So we need 10 microliters of our working solution, of our stock solution, so or 0.01 milliliter stock. But we want to have 10 milliliter of total solution. How much water do we have to add? So we've got a stock. We put that into our vessel. And then obviously we have to bring it up to 10 milliliters. So how much water do we need? Well, it's simple. It is 10 milliliter minus 0.01 milliliter and that simply is 9.990 milliliter of water. 9.990 milliliter of water plus 0.01 milliliter of stock together gives our 10 milliliter of our working solution. Make sense? Get some practice with that stuff. Are you happy with that? seems to me somehow, and please correct me if I'm wrong, seems to me that you're a bit flat today. Long week, eh? Huh? You what? Yeah, it's usually week 3, week 4, where sort of. Tell you what, if you promise me that you go over and do some practice questions. Here. If you promise me to do that over the weekend, and also to look at these two here, concentrations of a substance after dilution and calculating concentration of a mixture, at the videos and the calculation. If you promise me, do you promise me to do that? Yes. Have a good weekend.